All right. So, we have our first question, and it tells me, in some circuits that are used for decorating, one burned light bulb will prevent all of the other light bulbs from lighting. In other circuits, one burned light bulb will have no effect with the other light bulbs. In which of these circuits will the other light bulbs still light even if one light bulb is burned out? So I'm going to say, which one of these will other light bulbs still light even if one light bulb is burned out? So first, what I'm going to do in my answer choices, I'm going to track the path of electricity. So negative to positive, that means that is a series circuit. This is an example of a series circuit. So I'm going to write it down next to it. You're doing this with me because otherwise it's your homework. Series circuit. Now in a series circuit, if one of them go out, all of them are going to go out. So this is not my answer. B. This one is not even connected in the right way. It's going positive to positive, so none of it is going to work for B. Now D, it's going positive to positive. It's not going to work either. This one's negative to negative. It's not going to work. None of these make a complete circuit, so this is incorrect. The only one that if one light bulb goes out and the other one stay lit is this one because it's a parallel and everyone has its own path. So I'm going to circle it and make sure that I say, well, if this one goes out, it doesn't matter. It's going to still have this one, this one, this one, and this one light on. So the answer was C. So check yourself or fix it. All right, next question. Okay, this question tells me, the toy oven shown uses a light bulb to bake small cakes. What types of energy? You need to circle types of energy and say melts. Does the toy oven use to bake the cakes? Okay, well the first thing that I see is that this one needs to be plugged in. For sure, so it's going to use electrical. And then also since it's going to bake it, it's going to be hot. So it's going to be thermal because that's heat. So I know for sure these two are going to be used to bake these cakes. So where is it? Electrical and thermal? Yep. Mechanical? No, because nothing's moving there to bake the cakes. So no. Sound? That's not why we turn on an oven, to hear the sound. Okay, and mechanical is not right. So my answer was F. Electrical and thermal. Okay. No, question number 4. This one was a little tricky. It's telling me an old-fashioned metal toy shown below. When the candle is lit, the carousel of horses begins to turn. Okay, which of these correctly describes the energy that makes the carousel turn? Okay, what's going to happen here is that there's going to be heat coming out of this candle because the candle makes heat energy. So if the warm air is rising up, then it's going to make these horses turn. They're going to be turning. So, let's write this one was a little bit of a tricky question. So first, I want to make sure that I eliminate the answers that say light. Because light is not going to produce anything. It's going to be the heat. The heat that's coming out of this candle. Now, for those of you that have been in a fireplace, you know that there's that heat rising up. And it's making those currents of heat rise up. So, is there anything electrical plugged in there? No, so that can't be my answer either. So B, C, or D cannot be my answer. My answer was A. The heat from the candle produces currents of warm air, which makes it turn. But the answer choice there was because it's talking about heat, and it's talking about warm air rising up from the candle. Okay, next one. All right. It says students constructed a circuit using different color light bulbs. What would happen if switch 3 is closed and the other switches remain open? So I'm going to close this one out. Close it. Okay, I'm going to close it. I'm going to pretend that I closed it. Now I'm going to mark and I'm going to see what happens if I track my electricity path. So if I only close 3 and I remain these two open, I'm going to go negative, Yay, to positive. So this one's on and this one's on. Now let's see the other ones. Oh, I can't keep going, so this one's not going to turn on. This one's not going to turn on. So the only ones that are going to turn on are white and yellow. So I'm going to look for that answer choice. Versus white and yellow. So the answer was H. Okay, let's go to number 5. Number 5, it says to recharge the battery for later use you don't want the light bulb to turn on. You do not want that. Which of the following switches should be closed? So it's asking me which one should be closed to recharge the energy or the battery. So I know this is a solar panel, which means it's going to be my source of energy for the battery. So I need to close R and T in order for that energy to flow. Because I'm going to go negative to positive and it's going to recharge it. So the switches there need to be R and T. So the answer was C. The other ones are going to cause either the light bulb to turn or it won't make it a complete circuit. All right, next one. Number 6. It says many types of fans are used in home. One type of electric fan is shown below. Okay, I see here that I can see the fan. In addition to mechanical move, which of these is produced as electric current passes through the circuit of this fan? Now it's talking about circuits. Circuits use light energy. We talked about that all unit, light energy. So it's not going to produce heat. It's not going to produce mass. And it's definitely not going to produce water vapor. My answer was H, because light energy are going to be for circuits. And that is talking about in that question is circuits. All right, last one, number 7. And then the rest you have to watch on your own. A group of students built the circuit shown below. The light bulb does not glow. It does not glow. Which statement best explains this observation? Well, first I'm going to track my path of electricity. I'm going to go negative to positive. Yay, that turns on bell. Now this bulb is not part of the circuit. So it says, well, the reason why the bulb is not on is because the battery is not charged. That is not true. The light bulb is not part of a complete circuit. That is correct. The circuit does not have a switch. That doesn't matter. That doesn't matter about the light bulb because this is not part of a circuit. So no. The bell uses most of the energy from the battery. No, that's not true. The truth is that the light bulb is not part of this circuit. So the answer was B. All right, the rest of the questions you have to do on the next